In this episode of the Kill Innovations podcast, I interview Chuck House. Chuck is one of those individuals whose impact we've all felt but didn't immediately realize. With the recent anniversary of Neil Armstrong stepping on the moon, Chuck turned out to be timely in this interview. Why? He's the inventor of the early display technology that resulted in Chuck ultimately creating the Moon Monitor. It was the Moon Monitor that allowed NASA and the rest of the world see Neil Armstrong step on the moon. Now, the interview lasted more than 2 hours. The following podcast is just a few of the highlights. Enjoy.
This is the Killer Innovations Podcast with Phil McKinney. Keep in mind that the information and opinions expressed in this podcast are Phil's, and Phil's alone, and they don't necessarily reflect those of his past, current, or future employers. Now, here's Phil McKinney.
Talk a little bit about how did you get into HP?
How did I get into HP?
So how'd you get into HP?
Well, it's interesting. First thing was I interviewed because they were on campus. They were the first.
Where were you? Where'd you
I
go?
was at Caltech.
Okay.
And I was a physics major, and I had had one lab that was pretty good. I didn't know anything about AA. And they were looking for AAs, and somebody said, you ought to go use this as a practice interview to learn what it's going to be like when you go talk to real companies, right? So I went. And I liked
HP was your practice interview.
Yeah, and I liked what I heard. And about 3 weeks later, I haven't told this story in a long time. About 3 weeks later, I get, actually, all the guys that got reject slips got them. And all the people, three people, got a letter, said, come on up and visit us, right? I didn't get either one. So I called and said, hey, I didn't get either one, but I've got an interview with Sylvania. Could I just tack a day on with you guys? Sure, come on over, right? So I come on over. I got an offer about 4 weeks after that, addressed to another guy in my class.
Well, your offer letter was actually addressed to somebody else's name.
Yeah. My address, his name. So I accepted. And in my personnel file, I think it's still probably here. I Lou Platt on my exit interviews. Look, who the hell was so-and-so? Because here's your offer letter.
You got an offer letter with somebody else's name to your address, and you went ahead and accepted. So you're not even sure if the offer was coming to you or to the other guy.
I don't know to this day.
But you accepted.
I accepted. I got here, and Barney Oliver wanted to interview me. He hadn't interviewed me during the interview time, and he said, well, who exactly are you? and he put me in the scope division. And the reason was, he said, everything else we have is number one. He says, it's the only division to be in that you got a chance to go up as well as down, right? And he said, creative guy like you, it'd be really cool. And besides that, your mother's from Colorado, I see here on your form. And we're going to Colorado with that division next year. And I said, I don't want to go, except I'd love to go after I get a master's at Stanford. If you'd let me do that on your bill, I'd go. Now, my thinking was, I'll stay the 2 years, get the degree, and boogie. Turned out I stayed 2 years and got the degree and went to Colorado Springs.
And you went to Colorado Springs.
Did 28 years, 10 months, and 27 days later, I left HP. But fundamentally, every 2 years, I interviewed elsewhere for 28 years.
You did?
Yeah.
Why?
You just stay current. What are you worth? And what happened was I wound up having to change what I was doing because you don't stay current.
You find out you're not quite worth as much
You're
as you
not
think.
worth as much.
You don't think
you get a groove. So I've got 4 degrees in 4 major schools: business, engineering, science, and humanities. I've got 5 minors underneath those 4 majors, and I've worked in 5 disciplines, one of which is one of the 9.
Only one.
Only one. And I think what that says, and I don't think I'm completely rare in that respect. I think this world is such that you can't imagine studying something that's going to be of much value later in life. Learning how to study, learning how to cooperate with people somewhere you're not, and learning how to be empathetic to the needs of what's out there is the only game you can succeed at. So every couple of years, I would sample, what's going on out there and change what I was doing to some degree. So I was in 13 divisions. I started like 11 divisions in some form or another.
Well, that's back when the divisions, Bill and Dave had kind of had this rule of thumb when a division got too
split
big.
It at 500 or 600 people or 1,000 people, and
then split
it off. Yeah.
What was the thinking behind that? Why? I mean, it's kind of, I know it's kind of the keep small
Barney
thing.
had a great theory, and the theory was if you find a company of 10 people, there's always a genius. Find a company of 100, there's a couple. Find a company of 1,000, there's only 3 maybe, right? And he said, and here we are, 5,000 people. When we get to 10,000, how many are we going to have? And we all said, this is our opening dinner. And we all said, 4, we know that rule. And he said, no, none. They'll all been driven out. He says, so we're going to parse it n times 1,000, and we'll have 3 times n geniuses around. Hewlett had a different stance, and the stance he had was he wanted an informality about the thing. And he said, the whole way that other companies operate is they'll have engineering as a discipline, manufacturing as a field, marketing as a specialty, and they'll house those in different buildings. I want to have the team eating lunch in the cafeteria together. And then if something's wrong that isn't selling, the QA guy says something to the engineer, says something to the marketing guy, the feedback loop gets closed. And he said the only way that can work is if you know each other by first name and you sit down at that table. And he said past about 500 people, you can't remember the names.
Part of a lot of the curiosity that people have about HP from the early days, because you think about it, 2 guys in a garage come together, and now you see this, #1 technology company in the world.
Right.
But you think about the early days, because it really set the values. So talk a little bit about kind of those early days, because you came in 60.
Well, I came in 62, so it was 23 years old by the time I got here, almost $100 million. I was the 98th engineer, so it isn't like, it was not a huge set of people. And my dad's reaction was, how come you didn't go to a real company? Bell Labs exists and IBM exists and all that. But Dad, I think this is going somewhere. he finally, like in 1990, buys 1 share of stock or something so he could track it, But the thing about early was Bill and Dave were deeply involved in every project, deeply in the sense that they reviewed every project in the company every year. And there's something magic about that, especially in Bill's case, as technical as he was. And then he would bring Barney Oliver to boot most of the time. So you've got essentially this what I would describe as a master's, if not a PhD level, oral exam.
Every year.
Annually. On your stuff. And the questions were of the form, what contribution does it make? Why is it ahead? What's the next step after this? And what's the science underneath it? And the view was that this is instrumentation science. That you can't go to any school in the country and learn instrumentation science. You can learn how to be a double E, you can learn how to design circuits, you can learn, biology or astronomy, or you can learn a lot of disciplines, but nowhere can you learn instrumentation. And that's what we're about. And so the notion is you got to be part of a team, and the team has got to understand all the science around that particular thing you're working on. Not just how you build it, but what the application will be, and what you're going to be measuring, and who the people are you're going to be doing it for. So you wind up knowing oceanographers and astronomers and biologists and chemists and things like that at more than a peripheral level. And that was the drill. Every one of us had to go ride the Neely bus. Just telling my wife the story.
The Neely bus?
Yeah, the Neely bus. Norm Neely ran the California sales representative team. He bought a Greyhound and stripped it, an old Greyhound, stripped it, put 7 workbenches in it, had a microwave engineer's workbench, had a circuit design engineer's workbench, had a mechanical engineer's workbench, everything outfitted with HP gear. And your assignment, usually after you've been at HP maybe 3 years, was you have to go ride the bus for a week. What they would do with it is drive it onto the Redstone Arsenal at Huntsville or down to Canaveral or up to the main tracking station. And you and the bus driver knew all this stuff, and he got a 52-week assignment. You got a 1-week assignment. So you parachute in, and they stop. So I drew the Huntsville assignment. They stopped outside Intergraph, a little tiny company at the time, And Jim Medlock came out, and my job was to explain all 7 workbenches with probably had 50 instruments. And my plea was, I'm from Colorado Springs. I know about my product, and I know about scopes. And this guy's point, Sunday when I arrived, is he says, tomorrow you're going to know about every product on this bus well enough to describe it to a working engineer at Intergraph. Really? No one ever told me that. Well, that's a big deal. So you learn to be a generalist, not just in terms of, you're going to work around your program. You learned it around the whole Hewlett-Packard toolkit.
So how long did this bus go around?
It went around for years and years.
I've never heard this story.
Probably ended in, we built a flying bus for Asia when we opened Asia in the late 60s. Had a DC-6 that flew around.
So an HP DC-6, all equipped out with benches.
Fly to Thailand, and Philippines and Singapore.
And then invite the customers to come on, show them the bench, walk them through all the products.
Exactly. Yeah.
Oh, wow.
Huh? I mean, isn't that crazy?
That's crazy. That is crazy.
But it was an effective way to do things. And it was with Medlock at Huntsville that I really was able to understand for the first time. That's why the 1300 became the moon monitor.
Kind of have this reputation inside of HP as, the bull in the china closet, break a little china, step on some toes.
It's unfair. I was a perfectly normal guy. I just had a couple of excitements here and there that other people took in a strange way, and so that reputation gets built. And how do you get rid of the mythology?
So talk about the award of defiance. It's in David has it in the book.
Yeah.
So give us the Chuck House version.
So what happened was really pretty simple. I worked on the 1402 dual channel scope.
So this is an oscilloscope.
So my first assignment when I came to the company was I drew the short straw, and they had a good guy who left the company unexpectedly. And he was working on the flagship plug-in for the 140 plug-in scope line. And Tektronix was the only company beating HP at the time. So this was sort of, a front and center project. What I put on it was a Boolean algebra trigger. So it was a 2-channel scope, and you could do A plus B or A minus B or minus A plus B, or you could do the Boolean set for triggers, and no one had ever thought about that. And the reason for that was IBM was just starting to do AND gates and OR gates. And so I thought it'd be fun to be able to trigger on a gate like that. So it was kind of a novelty. I got to see some IBM stuff early. This is 1962-3. My second project was we figured out how to stabilize the scope screen. So we had a feedback circuit that we would sample 5 times a second on the front, compare it to ground, and then these are all vacuum tube stuff, so the trace always drifted all over. So you always had to every measurement, you had to recalibrate where ground was, essentially. This thing would do it automatically. The problem was I couldn't figure out how to stabilize 2 channels at once. I could figure out how to do one. And my boss thought that was great. In fact, he had helped work out all the formulas, and it was, elegant. So we had 1 channel stabilized really well. It was to be a comparator scope. You're going to compare an unknown to a known, right? The problem is it's useful to have 2 channels if you're going to compare something to something else. And he kept saying not to worry about it. We got this thing done, and not very many customers wanted one for exactly that problem. And I'm like, well, shit. You could do a thought experiment on that for 10 minutes and conclude that's going to be a problem. Why didn't we test it on the market? And the answer was, at the scope division, if we show anything in advance, the customers will call Tektronix and our secrets are out, right? We get an FAA control tower spec in like weeks later, and they wanted to take these 4-foot long, great big cylindrical things and shrink them so that you could have more terminals in a control tower to watch planes. And we had hired the guy who did those tubes for GE, and he said, I've kind of perfected the expansion mesh lens. And it basically was, you took a mandrel that was shaped like Mount Fuji, and you smashed this thing down on it. And so you built this conical lens, looked more or less like 1 cup of a brassiere. And the lens, the electrons would come, and then they'd hit this lens, and they'd bend, so you could get a very wide deflection. So I could do a 14-inch CRT with a gun that usually drove a 5-inch CRT. So I had this big picture. And then the question is, who wants something like that besides the FAA? And the first problem we discovered with the FAA is not only did it bend the beam, it expanded the spot size. Okay, so you could show the plane circling around, but when you wrote UA-72, it was more or less like writing it with a paintbrush. So it didn't quite solve the problem. So I had an elegant solution for a problem that didn't work. So I kept thinking this would be useful for graphics, you know, classroom graphics or who knows what. And everybody was just, you got to be kidding. And they said, this is an answer to your question, by the way. They said this would be good for nearsighted long arm engineers or for watching Gandhi in 3 minutes, because we could do, it was a 20 megahertz XYZ, or 20 megahertz XY, and a 1 megahertz Z. So the idea is, you know, it's a very fast television set, or it's an oscilloscope for a guy with very long arms. And that's about all you can think of. And the marketing forecast came back at 31 units.
Total.
Okay. And that's what they told Dave at the meeting. And so Barney was excited. He said, the mandrel won't work, that technology won't work, you won't be able to build it with enough linearity. And I know, because I invented stuff on the East Coast for Harrison Labs, and I've got patents, and you guys can't do it. So I flunked the technical evaluation with him, but he couldn't figure out on screen that it was nonlinear. And it turned out I'd built a linearizing circuit with a whole bunch of diodes at all. And if he flipped the times 10 switch, I'd have been dead. But he didn't ever flip it, so that was great. And so I had a technical guy voting no.
You faked your review.
And then Bill Terry, who was later a VP of Instruments, was the marketing guy, and he says 31 units. But I'm not in the room then. I've been shunted off to go back to the lab. And Packard says something like, well, when I come back next year, I don't want to see that product in the lab, that project in the lab. We had about another 2 years to go. We thought things were more leisurely back then. Next morning, I come into work, and my boss, the engineering director, says, we've got to cancel the project. Well, why is that? Well, Dave said, Bill said 31 units, and Dave said, when I come back, I don't want to see it in the lab. And well, 2 questions. They didn't talk to my dad. He wants to. So shit, that's 6% of the market right there, right? So they've underestimated. I'll go check it out. On the 155, you guys never ask the customers. I know where to go ask. So let me do a market research trip. And if I find anything, we can have it done inside the year. It won't be in the lab when he comes back. And my boss said yes. And I didn't view that as anything other than, hey,
don't give up.
Yeah. So we got it done in 10 months. We had it on the street. Packard shows back up, and he says, we're in a division review, and I'm up on stage, and we had just changed marketing managers from Terry to Hal Edmondson, and he says, Hal, is this thing selling? Oh yeah, it's selling beautifully. It's selling, well, where is it selling? Well, it's selling to all the same customers that buy our scopes. So we're not screwing up the channels, kind of, that I stand up to talk about what the next project is. And I said, well, what he meant to say, it's actually selling some very unique places. We sold one to DeBakey to do the first artificial heart transplant. We sold one to Doug Engelbart for the Fall Joint Computer Conference thing. I didn't know then that we sold one to Alan Kay for what became the Flex machine, the predecessor to the Dynabook. And I didn't yet have the Emmy Award out of Hollywood, and we didn't yet have the Moon Monitor. But I said, this is going, we sold one to Argonne Labs, we sold one to, all these neat places. Packard was just livid. And he said, I thought I said to kill this son of a bitch. I said, no, sir, what you said was you didn't want to see it in the lab, and it's not. It's in production.
But then what did Dave say?
He kind of grumped, but he said, well, so let's talk about what's next, and we talked about it. And then we had an 8-channel medical box being built, and then I got a journal article, and the labs never talked about it. Mazur never talked about it for the next 4.5 years, but the annual report every year had it in the annual report somewhere. It was the first display out there for computers.
So when did you get your?
So 13 years after that, well, no, 16 years after that, I'm going to come out and be the corporate engineering director. And the going away gift in Colorado Springs on April 1st, 1982 is what the certificate says. I get this thing presented by my boss, actually by the division manager, to the site manager. I was the division manager. That said, Medal of Defiance, signed Dave Packard. And I thought then it was a joke. I mean, just a roasting, it's a classic, right?
Fake thing or whatever?
Yeah. And I'm out here, and it gets printed in Gifford Pinchot's book, and an HPPR, came up. So we got this book, and you're taking the Lord's name in vain, and Lord is in that next office, and I sat next to Dave. But he was, he's sort of retired at that point, so it wasn't like he was there daily. But your whole career flashes before your eyes. You think, if I show him this chapter, I'm dead. And if I don't show him, I'm dead. So I walked over and I said, I've got this thing here, and you probably don't remember this situation, And he scans this thing for about, 10 seconds. He says, young man, and when he straightened up, he was like 6'5" or 6'6", big guy. And he says, young man, I was 42 by now, and he says, I remember that just fine. Well, working actually with Anna Mancini and some others, I found out they had gone to him, and he thought it would be a good thing to do, because his feeling in the early 80s was we'd kind of lost that impertinence, and he wanted to make an example of it. So I think it came about more because he thought it'd be useful to have a stalking horse than anything else.
One question I always ask people, particularly the people who've been around who actually got to spend time with Bill and Dave, tell us a funny story of both Bill and of Dave. If you think about that one story, that.
Well, there's 100. I'll tell you the one that my wife enjoys, and that is, these guys were my idols, but I knew them young, and I knew them personally. The advantage I had starting when I did is they were very active in the company, and I got a chance to present a lot to them, and I knew them well. I'll tell two stories in a row, and the first one's quick, and that is Hewlett came out, and actually they all came out for a division review, and they brought Louis Alvarez with them. And I drew the short straw to drive Hewlett and Louis and one other guy, I can't remember, to the Broadmoor for dinner. And we're on our way, and I had given a pitch, this was 1977, and I'd given a pitch on where the world in the year 2000 would be to the board. And Bill starts arguing with me in the car. And then he starts arguing with Louis about, so this is a Nobel Prize winner, right, in the back seat. And he says, Louis, I don't know how it's going to be in the year 2000, but he says, one thing I know is we're eating the seed corn. All the Silicon Valley is sucking up all the new PhDs, and they're going into industry, not into teaching, and I'm just worried about, we're eating our seed corn. And Louis said something witless, and I had a flashback that when I was in junior high school, I had an assignment, 1955, to write to two scientists to find out how to become a scientist, right? My science teacher. So I picked Louis Alvarez and Jonas Salk, because polio vaccine had just been invented, and Louis had just found californium or one of the rare earth elements. And I said, hey, I wrote to you, back then. And he said, what'd I say? And I said, you never wrote back. I said, Salk did, but you didn't. And Hewlett is just upside down over there laughing at me and hell. He said, yeah, that's exactly what I'd expected. And Louis starts this defense of, well, I was getting a lot of letters, and it was really a busy time. And, and then he says, but, you're doing okay. So not to worry.
You just got an award.
Yeah.
Not quite the same as getting the award from David for being the renegade, but recognizing the work that you did earlier. Talk a little about the IEEE award that you...
Well, I just got the ACM Fellow Award,
which
is actually... so the IEEE award is a good one. It's something like 1% of IEEE people get it. The ACM fellow is more like 0.1% get it. It's a pretty prestigious award. And the reason I never thought I'd get it is because they don't acknowledge that what I did was software. Just like the Computer History Museum doesn't acknowledge that HP builds computers or built anything that ever mattered, because they didn't pioneer the Mark I. They don't deserve credit, And most of the software I did was microcode, or was screen graphics, or was, we did Motif and Vue, and we did lots of stuff, but it didn't count. It's not, I wasn't programming in Fortran or PL1 or crap like that. And so I got this award, and the neat thing was I'm standing beside Alan Kay, who just got the award the same time, and Pat Hanrahan, who did all the rendering for Pixar, and then Bill Buxton. And anybody that knows GUIs, Ben Schneiderman and Bill Buxton. Bill did real stuff, and Ben wrote about it. So to have a cohort, there were 40 of us inducted, so it wasn't like it wasn't a singular award, but black tie deal, and I felt pretty privileged to be standing there next to Alan. Felt very privileged. I've been lucky. It's been a great life.
So what are you doing at Stanford now?
Well, in some ways, this is a capstone. In another way, it's like I'm a novice. Twice earlier, once at Stanford in the 80s and once at Santa Barbara in the 90s, I felt that a course or a curriculum around information technologies and their impact on society would have value. That there's something to be said for getting communication and computing together. I mentioned that earlier. Or getting psychology and engineering together, or whatever. In this case, we've actually turned it into kind of an art form in the sense that we're an industry-facing group, and the idea is that what you want to do is understand the implication of the tools that are being built. Mm-hmm. It's pretty easy for an HP to find Hanrahan today. Right. You know what he's done. If you want to do work in 3D rendering today, or you want to do work with data visualization toolkits, you find him. Hey, Pat, want to work for us. And and everybody at Stanford is funded pretty well, so it's got to be an interest equation for them to want to do it. What's hard for Stanford faculty is to work across departments. So we almost purposely set up things that if it's an edge question, how do physical and virtual worlds intersect? Or what does trust have to do with HP Halo? Do people walk in and does this engender productivity, or is it off-putting? Those kind of, there's no department of trust at Stanford. There is a trust department, but it's over in the financial side, looking at how our portfolio melted down. But so we try to tease out. And we think we're pretty good at teasing out, getting people to work on these cross equation things. So case in point, Pat got a research grant from us not long ago to look at how to instrument avatars in a virtual world. We funded a French literature guy and a Russian medievalist to put together a Second Life instantiation of the Hotel California. And they go out, they build a great thing. They won awards in Brussels. They get people coming to their site. And the next thing what they designed was the kids could have the ending of the movie different. They could move the furniture around. What happened, though, was the users that came tore the hotel down. And that was not allowed. And so these guys said, and I said, go talk to Pat. And they said, computer science has never listened to humanities department. They won't even listen to us. I said, try it. We're all part of the same set of 7 projects. They walk over there, and Pat's immediate answer was, "Well, just put object locking on the walls, and you're done." Turned out that didn't do it. Then he says, "Well, just do configuration management for the set, and then you recreate it the next day." Turned out that didn't do it quite either. About a month later, Pat came to us and them and said, "We've studied this around the country. We can't find anybody that understands this problem. It's a cool problem. We're staffing 5 PhD theses on this project." A year later, we can report out that we now have a new open systems virtual world that Stanford's going to issue to the world called Siricata that'll launch in September, and a spin-out company. And MediaX did it. Just because we said, hey, this would be a neat combination.
It's kind of those, it's back to the old skill set of those strange connections.
You got it.
One of the things I get a lot from listeners of the podcast is a lot of high school students and kids going into college. Real passion and real interest to go, they want to be innovators. They want to be inventors, right? And the question I always get is, what college should I go to? What classes should I go to? How do I become kind of, that, they really got that passion to go create. So here's your opportunity. What advice would you give those people who really have a passion to be inventors, to be innovators, to really change the world? What advice would you give them? What should they do to get ready?
Well, first of all, I believe in experiments. Little experiments, lots of experiments. Learning by doing is just a panacea. I mean, you've got to get your hands dirty. You got to mix it up, whether it's hands or software you're playing with or whatever. But there's kind of a dual and here. If you're not grounded in math and science, I am convinced you're handicapped, because what you learn isn't formulas. What you learn is a way of thinking. And a way of thinking is a logical, ordered structure of cause and effect, or of relationships that work. And that ordered, structured way of thinking is crucial to being able to work through to a solution. The curiosity and the enthusiasm and the drive and the eclecticness is essential to the creativity side. But unless you can take that creativity and harness it so that you can make traction and get something in a resultant way, you're really handicapped. So I first of all would urge math and science, and I would urge it these days much more at the statistics and big systems and data visualizations and the kind of things that computers can help you with. I'm less interested in learning how to do calculus integrals and things like that. You want to know what calculus can do for you and what algebra can do and all that kind of thing. But just being able to think spatially and visually and organizationally is crucial. Being unafraid to make mistakes and that sounds odd, but there's an impressive body of people you interview midlife or even late life. I wish I had, and I believe I will go to my grave with very few. I wish I had done something. There may be a few of I wish I hadn't done something, but it's if you wished you had done something, get doing it. Yeah. I mean, that's what I tell people today. They say, God, I just lost my brother, or I just had somebody, death in the family. And well, are there things you want to do that you haven't yet done? And they, I wish well, hey, guess what?
Go do it.
Now's not a bad time to start.
Right.
Because, get going.
Right.
And the world today, in terms of the world is waiting for innovation, and it's waiting for it in a million ways. And you can find out the needs as quickly as just looking right around your own. I'd like cleaner water. I'd like my car to get 200 miles to the gallon. I'd like to, think of the Segway that Dean Kamen invented. That was a bold, imaginative stunt. A wheelchair that treats you like a human being instead of an entrapment device.
Chuck, thanks for coming in. Really appreciate it.
This series of interviews with innovation thought leaders is made possible by support from thenextbench.com. For more information on the series and to listen to the previous episodes, visit thenextbench.com.
Thanks for listening to this week's podcast. Please send your feedback. Particularly, I'm interested in hearing your thoughts on doing these kinds of interviews. The objective is to give you a broader exposure to others that are out there creating killer innovations. If you found this podcast interesting and you want to connect with other innovators, join the network. There's killer innovation groups now in existence over on LinkedIn and Facebook and a variety of the social sites. Also, feel free to follow me over on Twitter. Just do a follow, Phil McKinney. Also, pay it forward. For those of you that are regular listeners of the podcast, you know that my sole objective in the podcast is to pay it forward as a return to my early mentors. And when I asked them how to pay it back, they told me later in my career to pay it forward to others. All I ask is that you pay it forward. Thanks for the time out of your busy schedule. Look forward to talking to you real soon. Bye-bye.